Hello everyone, I'm Laura, and this video is brought to you by F5 and Opswat. In this video, we're going to be talking about deep CDR. Now, CDR itself stands for Content, Disarm, and Reconstruction. Now, deep CDR is an Opswat technology that's a little bit more sophisticated than CDR, but before we explain why it's deep, let's explain what CDR is in the first place. So, CDR is like boiling water to get rid of lethal and non-lethal microbes. So, we've all boiled the water before. And the water are the files, and the boiling process is the procedure that strips all active content from the file. And after completion, you can enjoy a clean glass of water without having to conduct exhaustive research on which threats you've avoided. Now, CDR is a unique frontier in the cyber world for its ability to catch unknown vulnerability threats and zero-day attacks, which often bypass traditional AV engines, sandboxes, and AI. CDR is preventative rather than reactive, and that's because CDR assumes that all files are bad, and therefore it rebuilds each and every file without having to classify it as malicious or not. Now, Opswat has taken CDR one step further and created deep CDR. And this means that we are able to prevent threats recursively. So, for example, if you have a JPEG inside of a Word document, inside of a PDF, we'll go in and rebuild each and all of them. And so, to understand CDR, first we must understand the file transfer process. Okay, let's get started. So in the world, we have good guys and we have bad guys. And the bad guys will be the hackers and the good guys will be just our everyday innocent internet users. And both of these are creating complex files with elements such as scripts, embedded objects, LOEs, or macros. And the bad guys are trying to take advantage of these features. And for example, in simple file formats, they tend to target vulnerability exploitation. And so files from each of these are being sent over to the internet. And the bad guys are sending malicious files in order to target organizations, while the good guys are just simply using the internet. Now, an example of an organization at risk are web applications. And I'm going to go ahead and draw a single reverse proxy server and a pool of servers to represent a web application. Now, web application providers are often at risk because they are accepting files from unknown sources. So, for example, banks are accepting loan applications, recruiters are accepting resumes, and social media sites are often accepting media files such as video and pictures. And so these files are coming in from unknown sources. And now, as these files travel through the internet into your web application, they eventually might reach either a NAS or an S3 bucket. And this bucket, and then there might be another, let's say, there might be other users which have access through this to this storage. And so as these users, or let's say an internal application extracts files from the storage, they could also be getting infected. And so this is kind of how a network of computers can be infected within your organization. And ultimately, your entire business could be compromised because of these unknown file uploads. So how can we prevent the spread of well-conspired malware attacks in file uploads? What are some of the advanced tools in the market that we can use? And the reason why I'm talking about file uploads is because, as I said before, these web application providers are often taking in large sets of information from these unknown sources. However, the deep CDR technology can actually be applied on any reverse proxy server, forward proxy server, or storage device. Okay, so back to my question. What are some of the advanced tools in the market that we can use against file uploads that contain elaborate malware, such as zero-day attacks and unknown vulnerability threats? Well, for one, we can look at the OWASP. We can look at the OWASP website, and OWASP stands for Open Web Application Security Project, and they provide unbiased, practical, cost-effective information, and in this case particularly about file uploads. And so they suggest two things. So actually, I guess they suggest three things. First, they suggest that you take action at the frontier of your network. So here, where you might have an F5 WAF, is where you want to take place, because this F5 WAF is often, the gates of security of your network. And so they suggest that you draw your attention here. And as far as some of the other preventative measures that you could take is either block or rewrite. Now, what they mean by block is just preventing or denying a file from entering your network. And as far as rewrite works, that means you would take a file which is in a certain file format, you would convert it to a different format, and you would revert it back to its original format. And that's kind of how a rewrite works. And so what OWASP suggests that you do is that, let's say you have MS Office files which contain macros or OLE objects. Well, if that's the case, then OWASP recommends that you block these. And for example, if you have, let's say, a PDF with JavaScript or any kind of attachment, well, they also suggest that you go ahead and block these. Now, when it comes to image files, that's when they suggest that you use the rewrite approach. And this right here is the entirety of the OWASP recommendation. And so the downside is that there are many files which are not mentioned. For example, HWP files or JTD files or vector files such as SVG. And another thing is that there are a lot of different features of files that are also not being mentioned. So for example, in Microsoft Office files, what happens when you have comments, hidden text, rich text fonts, or animations? Like what happens in those? For example, in PDFs, you might have hyperlinks, embedded fonts, metadata. So there's a lot of features and files that OWASP doesn't really touch on. And so even if you use the OWASP recommendation, you might still be at risk. And another downside of using the OWASP recommendation is that if you start blocking all of these files, well, you might be obstructing workflow. And ultimately, you might have customer unsatisfaction or evidently revenue loss. So what can you do if you don't want to just block all of these files that you receive? And what happens when there are new file formats that are often coming out? Should you block all of them? How can you keep up with all of them? Now, would it be easier to clean the code? What happens if you accidentally miss something? Well, the better alternative is the Opswat Cdr approach. So I'm going to go ahead and draw Opswat related things in blue. So the Opswat Deep CDR approach, it doesn't have any prejudice about identifying which contaminants are in a potential threat vector. It just eliminates all of them completely. And then it restructures the remaining pieces back into a safe and fully functional file. Kind of like how this water boils both lethal and non-lethal microbes. And so after this process is complete, you can, files can egress into a network through a clean pipe. So what makes the Opswat Deep CDR special is that even if a file is zipped, then the Deep CDR will be able to identify and extract every single file in the archive. So it'll take care of this JPEG, of this Word file, and this PDF file. Now, only Deep CDR has the ability to do that. Regular CDR will not do that. And so, as I mentioned previously, this is the absolute best technology when it comes to zero-day attacks and unknown vulnerability threats. So what are some of the difficulties that might steer away a security architect from this brilliant solution? Well, for one, not a lot of people understand this technology, so there's a lack of education. Also, organizations might be hesitant to change the structure of a file. I have to say, it also doesn't work on executables, and there are certain types of encryption which it will also not work on. And another challenge is that even the experts at Opswat need time to write and test the code for files that are coming out regularly. So what makes the Opswat technology unique is that it is the #1 in the market for homeland security. Now, it can support all of these file formats, all of the fancy features I mentioned previously. In total, it has over 80 different file formats that it's able to support. Also, the file is still usable after rebuilt. So document features such as annotations will continue to work. And the integration process is fairly straightforward. There's actually a wizard app that does a lot of the configuration for you, and this just takes a matter of minutes. So, and finally, the technology can be bundled with multi-scan, engine vulnerability, and sandbox. Okay, so now that we understand the Opswat technology, let's go back to see where Deep CDR can be integrated into this file transfer process. As previously mentioned, we would like to integrate Deep CDR where one usually integrates other security features such as AVs. And that would be right here at the frontier of your network where your F5 WAF is. And Opswats recommend that you pair the Opswat technology with the F5 WAF because this duo has been around for over 5 years. And it's fully supported by the Opswat support team, which has a satisfaction rating of over 4.7 stars. And so here at your F5 WAF is where you want to place your Deep CDR technology. And the F5 WAF has exclusive features that John will explain.
Hey, thanks, Laura. Hey, everybody, my name's John. I'm with the F5 Dev Central community, and I wanted to talk to you today about the F5 technology and how it connects to Opswat MetaDefender. So it uses this protocol called ICAP, and that stands for the Internet Content Adaptation Protocol. And that protocol is used to connect the Opswat MetaDefender. So here's Opswat here, Opswat MetaDefender. And ICAP is used to connect F5 technology to Opswat. The different modules that can be used in F5 are the WAF, so our ASM, but also the advanced WAF, the SSL orchestrator, and even the LTM. So a lot of different modules can be used here on F5 to connect to the Opswat MetaDefender. So I wanted to talk really quick about how a file upload would happen given this entire solution that Laura has outlined here. So you have users, as she mentioned, some are good, some are bad. They're sending files in that ultimately they want to upload to your web application. And so we don't know if those are good or bad. So the files are going to come into the F5. The F5 is going to take any kind of action that it needs to take based on the technology that's here. Again, whether it's SSL orchestrator, AWAF, whatever it is. But as actions are taken there, it's also going to send the file down via the ICAP protocol to the Opswat MetaDefender. And then the MetaDefender is going to do all of this deep CDR that Laura talked about and sanitize and reconstruct and all that stuff. But while that's happening, Opswat also has over 30 different antivirus scanning engines that are going to scan this file. So this thing's getting scanned, it's getting cleaned, it's getting sanitized, it's getting looked at, very heavily. Once all of that happens, then the file is sent back up again via ICAP to the F5 technology, and then the F5 is going to take any kind of action that it needs to take before it allows this nice, clean, beautiful file to finally enter your web application.
Thank you, John, for that thorough explanation. So in conclusion, web application providers need to be wary of people who are misusing the internet to send over unknown vulnerability threats and zero-day attacks. Nowadays, there are a multitude of ways in which malware can be embedded either onto a simple file or a complex file and sent over the internet. I hope you learned something about CDR today, and hopefully this helps keep your network more secure. Thank you for joining us.